Okay, so today let's have a look at this question. This is a past HSC question worth 3 marks, and it's asking us to find the domain and range of this function here. Now, the domain, let's look at the domain first. We know by definition that the domain is all the possible values of x that this function can take. So if we have a look at what is happening to x here, you can see that it's been put into this square root symbol. Let me just make this a bit darker. It's been put into a square root symbol. Anytime you have a square root, there's a restriction on what values can be inside the square root. And we all know that numbers inside the square root must be either 0 or positive. So that imposes a restriction on this expression here. So there's a restriction here. So a way to say that everything in this green rectangle has to be positive is by writing 25 minus x squared must be greater than or equal to 0. 0 is also included because you can have the square root of 0, but you can't have anything that's square root of a negative number. So something like this doesn't actually exist in the real number field. So that's why we're saying that everything inside must be greater than or equal to 0. Now this equation is simply a quadratic inequality that we've solved before. So let's go ahead and quickly solve this. This is a difference of 2 squares. And in order to work out the solutions for x, of course, we draw a little parabola, and this one is concave down, so it looks something like this with the x-intercepts as -5 and 5. And because it's greater or equal to, we are shading everything above the x-axis. So this is the x-axis, we're shading everything above, just like we did in the previous topic. So what this tells us is that the solutions for x in this expression, or this inequality, has to be x is between -5 or 5. Now, what this actually means is that in our x function here, x can only be between -5 and 5. For any other values outside this boundary, you have a negative number. So for example, if you tried x equals to 6, that's outside this boundary. If I substitute 6 into this, I'm going to get 25 minus 36, which is -11. And we know that we can't have the square root of -11, right? It doesn't exist. So that's basically it for the domain. Very simple. Now the range is a little bit more difficult to find. So there's 2 ways you can find the range. The first way is by drawing the function out as a graph, sketching it out, and then just reading it off. Well, that's a bit problematic. We don't know what this function looks like. In this case, we do know, but let's say that we don't. Now, in the case that you don't know what this looks like, what you do is you find the lower bound and the upper bound. Okay, so what this means is, what is the highest value of y that can be found by putting any x in the domain? So let me sort of rephrase that. The upper bound is all the possible, or the biggest y value. So let me just write this here: biggest y value that you can obtain for some x between -5 and 5. And of course, the lower bound is the smallest y value you can obtain with the same sort of x values, so between -5 and 5. I won't write that again, I'll just put a little asterisk here. Actually, double dashes they're called. Okay, so having a look at the lower bound, let's try to sort of figure this out. You'll notice that in this expression, we have y equals to 2 lots of 25 minus x squared. So because we're subtracting x squared from 25, the smallest possible y value, what is the smallest y value that we can have? Well, that would have to be when this whole thing here is 0, including the square root, isn't it? Because you can't really have a negative y value. Like, there's no x value that you can put into here that'll give me some negative number, because square roots are always positive, and 2 times a positive number is always going to be positive as well. So the smallest possibility is possibly when this whole yellow thing is 0, right? And we can actually achieve that. Well, that's achieved when x equals to 5 or minus 5. So I might just pick 5 in this case. So when x is 5, well, what's y going to be? Well, y is going to be 2 minus the square root of 25 minus 5 is 0, and that will be 0. So that is what we call the lower bound. That's the smallest possible y value that we can generate. Now, for the upper bound. The upper bound is calculated again by the function. So because in this expression, again, most of the action is happening here. Now, for what value of x should I take away from 25 to make this y value, so to make this y value the biggest that it can ever be? Well, having again a look at the domain, right, we can only put values between minus 5 and 5. It makes sense that the best number that we can pick so that y becomes as large as possible is when x is equal to 0, when we take away nothing, right? Because if you put any other number in this interval into this x, you'll be subtracting away something. You'll never be adding anything because we're subtracting away a positive number. Remember, x squared is a positive number. So if I put in like minus 3, minus 3 all squared is 9. 25 minus 9 is 16. So I'll be sort of pushing this lower, right? It's going to become smaller. But if I subtract away 0 squared, I'm not actually subtracting away anything. So it's going to stay at 25. There's no other number in this interval that will make the 25 stay as it is. So x equals 0 has to be the upper bound. And when I substitute this in, of course, I get y equals to 2 square root of 25 minus 0 squared. And that gives me 2 times square root of 25, which is 10. Okay, so there's the 2 key pieces of information. You've got your, from here, y equals to 0, and here, y equals to 10. Hence, the range is just, actually I should write the whole thing, range is going to be between, y is between 0 and 10. And that's it for the video.